Was anschalten? Ah, jetzt, danke. Are you talking about bugs in the ASN1 standard specification? Or are you talking about bugs in the ASN1 tools that are common, the compilers and runtime libraries, whatever?
I'm talking about specific implementation bugs in separate re-implementations. So I'm not talking about a bug in one library and, oh, it's going to be a problem in all these programs that use it, like we had it with setlib. But no, it's independent re-implementations. Sometimes they copied from each other, but there are definitely a few independent implementations that had extremely similar bugs. So I have a second page here. So if you look at it, there's this Protos protocol test suite from the University of, I don't know, but just look for Protos. It's a protocol testing framework, and they... Oulu University in Finland, thank you. So Protos uncovered bugs in lots of these applications, and for example, if you look at, do I have it here? The GNU-TLS issue. I mean, GNU-TLS basically is a project that was started as a re-implementation of OpenSSL, and well, they made bugs in their ASN code, ASN parsing code again. So they re-implemented, but they still make bugs there. And I think there will be more bugs there. So because what I see from all this, even without being an expert on ASN1, it's just my intuitive feeling. If there have been so many independent bugs there, this must be a hard problem using C, because all of those bugs are in C implementations of ASN1. That's not, it's just empirical evidence that I'm presenting here. So I said it's a big picture talk, but I think that we will see less of those kind of bugs, so ASN1 might be easier to implement in a high-level language. Of course, it's not used that much in high-level languages yet, so we cannot know for sure. But I don't know of any ASN1 problems, similar ones to this, in any high-level implementations. And I know two, which is one in Java and one in Python. So it's a small sample size, so I might very well be wrong, so I'm open for discussion afterwards about this. Okay, so I think by just changing the way buffers are handled, you will not get so easily get memory corruption or memory problems. So, contrary to everything I've ever been taught in almost every conversation, there have been some exceptions, but very, very few. Most people told me, well, I'm keeping using programming language X because all programming languages are equivalent in their power anyway. You can do anything in any language. You might still even occasionally heard it from assembler programmers. So it's, well, and so syntax is relevant because we are dealing with a psychological problem. So the problem of developing software is a problem of bringing some idea that is in the head of people into software. So the bugs that happen are not, they are not bugs in the programming language, because you can write secure code and you can prove that theoretically you can write secure code, even though you cannot verify that some code you have written is secure. But the place to fix it still, in my opinion, is in the programming environment. Not just in the programming language, but the whole framework, the whole way we translate our ideas into code. So this is semi-scientific mumbo-jumbo. I present to you the random rolling marble model. So the susceptibility of a language for a class of bugs is the probability of a randomly chosen programmer to make a mistake from that class. So if you give the same problem to lots of programmers, you get statistics how likely you can exploit the same, you can exploit the same SQL injection attack in 5 different independent implementations. So what do I think are good programming environments that help with keeping the code secure? First of all, I think magic is often really bad. None of those rules are absolute because they're good counterexamples. So what do I mean with magic? I will show you on the next slide. Then this programming language should be sufficiently expressive. So if the programmer has to write something entirely different than the idea he has in his head, he has a problem because he needs more brain power to just understand what is happening. Then you want to avoid unnecessary redundancy because it leaves more room for making bugs. Less code is more than better code. You want sufficient Hamming distance between code words with different meaning, which means two things that mean different things should look different. So you can just skim over the code and understand or get an idea of what it is doing, and it also avoids typos. Then there's the principle of least surprise. So pretty obvious. You don't want to be surprised when you write security critical software or a banking transaction. Oh, that's nice. I can make a transaction from this account to my account. It's nice. So you don't want to be surprised there. So the best way to do things should be simple. The easy things should be easy, hard things should be possible. I shamelessly copied some of the points here from the Zen of Python because Python is really nice, secure programming language. There are other good ones too. Well, and now I'm bringing negative examples because this is what it's really about. There seems to be a big trend in higher level programming languages towards 2 or maybe 3 camps. You have the camp that is Java and .NET, and you have the other camp that is Perl, PHP, Python, and so on. So dynamic languages, static languages, and a few languages that go in between or other concepts. But these are the main camps right now in sheer numbers of users. And PHP is a big part of that. So I'm seriously using it to show bad examples of bad code. For example, in PHP, user input automatically is put in global variables. So if you pass just anything you want to any PHP script, it's put into a variable. And well, if you don't pass it, this variable is just undefined. You don't get a warning or anything. I mean, there's no data in there. So you have an unlimited amount of empty variables, and you never know that you just made a typo or forgot to pass it, and so on. So this can get a really bad problem, this second point. Especially if you look at the third point, how types are handled in PHP. For example, when two variables of different type get compared, one of them gets implicitly converted, which means ID equals myString is true if either 1, ID is a string that contains myString, or more intuitively, if ID is an integer with value 0, then myString gets converted to an int of value 0, and it's true too. So and one of the worst points is I sometimes have to work with PHP. So use whatever language makes sense, and if you have code you have to fix because that's your job, then work with PHP. So the problem is the only way I found, I asked on our RC channel back then, to download websites from a remote location is by having enabled fopen, include, and a few other functions to not only be able to open files, but also be able to open remote URLs. So that's really convenient if you want to say, well, give me that URL and so on. But in my opinion, it would. Let me point out the problem with that first. For example, with include, and you make a template system and say, I want to include the about page into my general template, so I do include about.inc, something like that, and you pass the about.inc in a variable, like many websites do that. They are dynamically changed, just pass to the main program the name of the include file for this specific page. And the user inputs an URL, then a remote file is included, and then locally executed. So this is a direct remote shell access. The problem with it is, I mean, you can turn it off, but if you turn it off, then you have to open a socket to a web server if you want to download something, send get/http 1.1 host colon and so on. So you have to build your own HTTP implementation if you turn off this feature. So this magic is really bad because it forces me to deal with a big attractor for security problems with no choice to just take the functionality and say, oh, I don't want to F open, I want the URL open. So you could just change, you don't want magic, you don't want one function to do different things dependent on some random variables and config file options. It's really weird. Then there's a problem that's common with many languages. The problem is there's not sufficient expressiveness. So high-level languages can help here. Because you want to express what you're thinking. If you want to iterate over like you want to make a pay raise for all your employees, you want to iterate over all the employees and give them a raise. So pretty obvious. You can write it down for element in arguments, do something to the element, easy. Up there, by the way, is a bug before someone points it out. So for X, like what are we doing up there? We want to iterate over a list. We are not actually using the variable X. I mean, I'm literally not using it here. Actually, instead of argv square brackets 1, there should be argv square bracket x. I made that bug in my first slides by accident. I left it there because it just shows you make those kind of bugs. There's room for bugs even if you don't want to do something simple. So down there, that's much nicer, and it works because of a high-level concept which is called iterators. Then regarding sufficient expressiveness, another negative example. If you want in PHP to read all the file names from a certain directory, you would do it like this. You would first store within the while loop to store it in $file, and then you have to compare using a type-aware. So PHP has this problem with automatic type conversion. So they introduced, to fix it, they introduced the equal and not equal operator. So we have another character there just not to do type conversion automatically, which every same programming language does anyway. So it just adds up, it's craft. Instead, we could just say, well, for all the files in that directory, give me the file name. So then there's the problem of code duplication, which makes it hard to read and maintain. So for example, Java has a problem there. It's getting better with things like generic containers and genericity, and also with aspect-oriented programming and ideas like that. But still, the statically typed languages do have a problem with code requiring to be duplicated. So maybe someday someone will solve that. Right now, it's a big problem. Then there's double use. This is a controversial point, but there's double use of the brackets and the indentation. So if you ever taught a total beginner how to program, you will notice they all the time have problems with right indentation. So either they make the wrong brackets, the wrong amount of brackets, or it doesn't match with the indentation, or the other way around. So they always confuse this. So one of the reasons why I really enjoy teaching Python to total